Sagittarius A asterisk, often abbreviated to Sgr A asterisk and pronounced Sagittarius A star, is a supermassive black hole located at the center of a spiral galaxy, the Milky Way. In 2008, astronomers Reinhard Genzel and Andrea Ghez determined Sagittarius A star to have a mass 4.3 million times that of the Sun. Astronomers have also calculated that the diameter of the Milky Way's supermassive black hole is around 14.6 million miles, that is 23.5 million kilometers. This is tiny compared to the Milky Way itself, which is 100,000 light-years wide and 1,000 light-years thick. Also dwarfing Sagittarius A star is a disk of gas surrounding it that extends for between 5 and 30 light-years, occasionally feeding matter to Sagittarius A star, causing faint flashes of X-rays. This accretion disk is also connected with X-ray emissions caused by friction, driving temperatures in the disk up as high as 18 million degrees Fahrenheit, that is 10 million degrees Celsius. Everything in a 13.6 billion year old galaxy orbits Sagittarius A star, including our solar system, which is located 26,000 light-years away. Hi, this is Sudhirtalati, and today we are going to be looking at how was Sagittarius A star discovered, and will Sagittarius A star swallow the Milky Way? Before proceeding, be sure to subscribe to our channel if you enjoy videos like this. Theories surrounding Sagittarius A star and its massive occupant date back to the early 1930s, when Carl Jansky found a radio signal emitted from a location in the direction of the Sagittarius constellation directed towards the center of the Milky Way. The galactic center compact radio source, Sagittarius A star, was then identified in February 1974 by astronomers Bruce Palek and Robert L. Brown. It was during the 1980s that astronomers formulated the idea that the central compact object was likely to be a black hole of a size, until then, unimaginable. In 1994, Reinhard Genzel and a team from UC Berkeley used infrared and submillimeter spectroscopy to infer a compact object with a mass 3 million times that of the Sun in the region. Over the next decade, astronomers continued to rule out other possible candidates for this object, including tightly clustered stars, which strengthened the idea that Sagittarius A star is a supermassive black hole. Conclusive evidence that the compact object Sagittarius A star is a supermassive black hole was delivered in 2018 when emissions caused by magnetic interactions from hot gas clumps close to the black hole, moving at around 30% the speed of light, were observed by astronomers using the European Southern Observatory, that is ESO's Very Large Telescope, that is VLT. And finally, on May 12, 2022, scientists unveiled our first view of Sagittarius A star in a striking image. The image was captured using observations of light, the light emitted by matter that's heated up as it hurtles towards the center of Sgr A star. This technique gives scientists a view of essentially the shadow of the black hole. Capturing an image of a black hole is no easy task and requires a global network of observatories that coordinates to act like a telescope the size of Earth, the Event Horizon Telescope, that is the EHT. The resulting image, Sgr A star, is the work of more than 300 researchers across 80 countries over a period of 5 years. These observations exactly matched theoretical predictions for hotspots orbiting close to a black hole with a mass of 4 million solar masses. It's a common misconception that black holes suck in material. Instead, they just capture in their gravity any matter that ventures too close. So if the Sun were replaced by a black hole, Earth would remain stable and safe in its orbit, albeit robbed of heat and light. Many black holes consume material, gas and dust, or material ripped from nearby stars, surrounding it in an accretion disk, gradually feeding matter to the center. When this happens, the violent conditions in the accretion disk create powerful emissions and jets from an area that is called an active galactic nucleus, that is AGN. Sagittarius A star isn't currently swallowing enough matter to power an AGN, and a star or other object would have to hit it almost directly to be consumed. This could change in approximately 4 billion years when the Milky Way collides and merges with Andromeda, disturbing stars and providing another, potentially much larger, black hole for stars to stumble into. If you enjoyed this video, please like and subscribe to my channel. This is the fuel for me to make such informative content like this. Thank you for watching.